Let's run this program. So the program is running. I am using the constant values, right? So here I have defined maximum and minimum value of the voltage, right? So let me run the load flow. So after when the load flow completes, so it says no voltage violation found on any bus, because here you see all the voltages lies on this range. This is the minimum voltage and that's the maximum voltage. So if I change, let's say if I change the my minimum voltage to minimum value to, let's say, 230, so see what will happen. So I'm making it 230. Now you will see that there are multiple voltages. There are multiple voltages. Let's make it 228. There are multiple voltages that might fall below 228. So it will show that there are certain buses in which the voltage is violated. So you see bus number 3, 4, 5, 6, 7, 8, 9, 10, 11. There are many buses in which the voltage violation has occurred. The other has the voltage that lies in this range. So you see the bus 1 has the voltage 228.15, which is above 228, so it is not violated. Whereas in the bus 2 the voltage is not violated. But on the bus 3 you see the voltage is less than the minimum voltage, so the voltage violation occurs. Similarly, you can create multiple scenarios, like you can make it 227 and run it again. So you will see the number of buses with the voltage violation. Okay, let me make it 225 and run it again. So you see no voltage violation found on any bus. So the voltage is in the limit. So this is how it works. You can change the maximum and minimum value. For your program the minimum value was 216, so you should make it 216, and you should run the load flow by changing the values of P and Q. So you will see if the voltage is violated, means it is not in the range. It will give you the indication as well as the bus number to show that the voltage has violated.